Good morning, everyone. I'm going to talk about my group's project of solid-state drones. So you can see, drones have a potential to really revolutionize how we do logistics. They can enable near instant delivery with no emissions, no traffic, much reduced labor costs. And as a result of this, many very established players have been looking into this space, like Amazon, Google, DHL, and so on. And they have the technology to do this. But so far, deployment's been really limited. Why is that? Well, the issue is they're too loud. They're effectively a huge nuisance to the communities they serve. So this here, that was a sample from an actual community trial that took place in Australia recently. That's very annoying. In fact, from that trial, they found that noise was by far the majority negative sentiment of the community from that trial. And things like that they've pretty much killed deployment of drones commercially, because with community resistance comes regulatory resistance, which makes it really hard to deploy. So how can we reap the benefits of drone delivery without annoying everyone that we serve? Our solution is EAD propulsion. So this is a new form of propulsion that instead of having moving parts to generate thrust, we use electric fields. So we have in the front, we have an emitter electrode, and we have a collector electrode in the rear. By creating an electric field between them, we can ionize the air and then accelerate it. When you accelerate air, by Newton's third law, you get a thrust force in the opposing direction. So why is this interesting for propulsion? Well, like I said, no moving parts. There's two benefits of this that we see. The first one is reduced mechanical wear. There's a few applications where this is interesting, but it's not really the main driver. The far more interesting one is no noise. Since in a propeller-driven aircraft, the propeller is a source of by far the majority of the noise signature. So how's this worked for us? So we started off developing this in the lab. Then a few years ago, we put this onto a tech demonstrator aircraft and demonstrated that flight powered by EAD was possible. Now we're working on extending that into the product we see here, which can hopefully do outdoor flight on a realistic mission with a sample payload. Then following that, we hope to continue to iterate on it until we have something that maybe looks like this, a potentially usable prototype that could be used to carry packages. So we've demonstrated that this can generate thrust. So this here is the actual prototype on our static thrust stand of our setup. It is a biplane about 3 meters wide with numerous thrusters running along the length of the wing. And when we hook it up to our operating voltage, which is about 50 kilovolts, we can generate over 2 newtons of thrust, which is comparable to what a propeller on an existing RC scale aircraft can generate. More importantly, though, this thrust is generated silently. So this plot here shows the noise signature of our EAD thrusters in orange compared to a propeller with the same thrust in green. And you can hear this is the propeller noise. It's kind of loud. And that is what our thruster produces. There's a very clear difference, particularly in the zone of frequencies where the human ear is most sensitive. So again, propeller, EAD. It does sound different on these speakers because they have really powerful subwoofers here, but whatever. And most importantly, we know that we have shown that this can actually propel a real aircraft. So this here is a demonstration from our flight that happened in, I believe it was late 2018. This aircraft here is flying, now there is no audio on this clip, but it is flying entirely propelled by these types of thrusters. Now this aircraft only flew in a straight line with no payload. What we're working towards now is this aircraft, which extends the capabilities of this into outdoor flight on a curved trajectory. Currently, we're on the stage of test flying this airframe before we implement the propulsion system onto it. So what's next? What do we need to do now to take this from a tech demo to a product? Well, there's 4 things we got to do. The first thing is we have to iterate on the aircraft. We have to firstly improve the aerodynamic design so we can get as much performance out of our thrusters as possible, as well as increase robustness, since one of our current problems is if it crashes, we have to rebuild the aircraft. That's another 6 weeks of dev time. Power electronics is a big problem. The voltage range at 50 kilovolts is quite substantial, and we need to generate that from a battery on something that can fit on a very small drone. That's challenging. We also got to do more development of our thrusters. We're currently working on a few new configurations that we think may yield order of magnitude improvements in thrust. So instead of 2 newtons, we could get up to 20 newtons on an aircraft. That could almost enable things like VTOL, which would be really helpful for new applications. And then finally, we need to test fly it outdoors to prove that that this actually is useful for an aircraft, not just a lab toy. And with that, hopefully we'll get a usable prototype. Thank you very much. We'll be at the poster sessions and welcome any questions that you might have.
Thank you.